So today's topic is probability theory, going back to basics. A quick review of probability theory, but we'll be spending some time on some important mistakes which people make in understanding the concept of probability. So this, let's start from the basics. Discrete random variables. So for this today's whole discussion, a good reference material is Bishop's book, PRML, section 1.2. Okay, so let's start with some example. Let us say I have got articles. One article is an article on a topic called rows. It contains many words. I have taken this article from Wikipedia, so it contains many words related to rows. Another article is on Jasmine. This article is also from Wikipedia. It contains related words. Now I can ask questions like, what is the probability of choosing the word red? So what is happening is I have got these two articles and I am randomly picking some word. So what is the probability that I choose the word red? What is the probability that if the word which I have chosen is white, then what is the probability that it is coming from the article rows? Or what is the probability that it is coming from the article Jasmine, right? Similarly, does the probability of any word like Asia depends upon which topic was chosen? So basically what we are referring to is we have got two topics. One is rose, other topic is Jasmine. These are like two baskets or two bags in which there are words. There are so many words in these baskets. Some words are repeated also. So if I choose a particular basket with some probability, let us say I choose the topic rose with the probability 0.7 and then I randomly pick any word. What is the probability that the word which comes out is red? Right? All these questions. So this is just an example. In practical life, you may get similar examples. For example, somebody makes a query on Google. What is the probability? Let us say I have in my database I have got 10 articles. One is rose, one is jasmine, one is marigolds, one is lotuses, different flowers. Somebody makes a query with some related keywords. What is the probability that he is looking for the article on rose? What is the probability that he is looking for an article on jasmine, right? So another example could be you have got speech. Somebody is speaking. Different words are possible. What is the probability that the person will say Alexa? What is the probability a person will say what is the time? What is the probability that he will say what is the weather today? Right? So there are certain high probability words which the model needs to be very accurate about. Okay, the person is asking about weather, so which is a very high probability word. So let us build models which handle these words very nicely, right? So probability analysis is very useful for wherever there is any uncertainty or wherever there is any human interaction, right? Because human interaction means uncertainty. So to take our example forward, so I have chosen certain words. Like this article has got so many words. Jasmine is a genus of plants. All these words are there, but I have chosen limited set of words. Jasmine, color, flower, red, yellow, white, Asia, scent, Himalayas, tea. These are the kind of words which I have chosen from this article. Similarly, from the rose article, I have chosen these words. Right? So these are the words and their counts in each topic. In the topic rose, the word rose appears 6 times. The word flower appears 2 times, like that. And in jasmine, the word jasmine appears 5 times, flower appears 3 times, tea appears 1 time, whereas in rose the tea does not appear. So, and assume that the topic rose is chosen with the probability 0.7 and topic jasmine is chosen with the probability 0.3, right? Now we come to these questions. What is the probability of choosing the word red? What if the chosen word is white? Which topic did it come from? Like that, right? So how do we handle such kind of questions? So we handle them with probability theory. First of all, we define random variables. So for these examples, you might intuitively solve for the right answer, but the general theory, we will go by the general theory. The general theory says that, okay, you define random variables. One random variable is topic, so which can take 2 values, either rose or jasmine. Another random variable is word, which can take all these values, Himalayas, jasmine, thorns, color red, etc. Right, so we have got 2 discrete random variables. The first random variable can take 2 values, second random variable can take maybe, let's say, 12, 13 values. Okay, now let us try to understand the concept of joint probability. What is the concept of joint probability? For example, the probability that topic is rose and the word is red, right? This is a genuine thing to do. What is the probability that if I randomly pick, so the topic is picked with a probability 0.7, rose is picked with the topic probability 0.7, and then I pick some random word. What is the probability? Finally, I will get topic is rose and the word is red, right? This is called the joint probability. Joint means we are considering two variables together or many variables together. That is the concept of joint probability. Now, very important concept, how to attain individual variables probability given the joint probability. That you all know, it is called marginalization. You marginalize over the variable which is not required, or integrate or sum over the variable which is not required, or over which you want to marginalize. Is this clear? These are all known concepts, so I think we can quickly go over them. So next is conditional probability. Given the probability of getting a word W, what is the probability of getting a word W given that the topic is T, right? If I give you the basket, okay, this is the topic, and randomly pick any word, what is the probability that the word is red? Or what is the probability that the word is Asia, right? So an example, so how we write it mathematically, it's probability of W is equal to red given that the topic is rose, right? And what is the relationship between conditional probability and joint probability? Very important, so this is the relationship. Probability of W given T is probability of W comma T divided by probability of T. So that is it. Now, okay, so this is called product rule. What is product rule? Product rule means to find a joint probability, you can break it down into conditional probabilities. Product of conditional probabilities. So probability of W given W comma T can be written as probability of W given T into probability of T. Clear? These all concepts are already, you are familiar with these, right? Anybody has any problem? Okay. Then, okay, the same thing can be written like this. Probability of T given W, we have seen, we can write it as probability of T comma W, means joint probability divided by probability of W. But you also know that you can write probability of T comma W as probability of W given T into probability of T, right? So this thing is known as Bayes rule or Bayes theorem. So, but what is the implication of this? Mathematically, it is very simple, but it has a very nice implication. For example, I ask you that given that the word which I have found is red, what is the probability that I'm looking for the topic rose, or the topic which is underlying, or which the topic from which it comes is rose? What is that probability? That is, if somebody writes on Google red, What is the probability that he is looking for Rose article out of those 10 articles? Or let's say out of these 2 articles. Yeah, I think this is a good example. So let us say I have got 2 articles and I am doing a Google search, or means limited Google search. I write red. What is the probability that I am looking for the article on Rose? Right? So this is not straightforward. I will come back to this point. Let's go back to our examples. So these are what I have done in this table is I have put all the words together. So in the article Rose, these words appear, but there are certain words like Jasmine, Himalayas, tea, they do not occur. Similarly, in the article Jasmine, the word rose, thorns, Latin, these do not appear, right? And these words do not appear in the topic Jasmine. So this table is very useful, the table of word counts with respect to topic. Okay, and you are given that the probability of choosing rose topic is 0.7 and Jasmine is 0.3. Let us go back to our questions. What is the probability of choosing the word red? Who can tell? The counts are given in front of you. What is the probability of choosing the word red? Pardon? Okay, so one suggestion is coming is 4 by 21 plus 1 by 19. Any other answer? Four by 21 into 0.7 plus 1 by 19 into 0.3. Any other suggestion? Any other suggestion? How about this? 4 plus 1 divided by 40. Is that correct? ABC, you've got 3 options. Okay. So instead of getting confused, I know probability theory is the most confusing topic. So go by the basics. So define a random variable W, define a random variable T. What you're looking for? Probability that W is equal to red, right? And I do not know what is it, but there are certain things which I know. What do I know? From these tables, what do I know? I know probability that topic is rose. This is equal to 0.7. Probability that topic equal to jasmine is equal to 0.3. What else do I know about red, let us say? Probability that word is red given topic is rose, this is equal to 4 by 21. Probability that word is red given the topic is jasmine is equal to 1 by 19. Okay. Now I want to find probability of W is equal to red. What should I do? What should I do? Probability of W is equal to probability of W comma T summation over T. This is also equal to probability of W given T, because I have W given T, right? W given T into probability of T summation over T. Okay, do I have PW given T? I do not have it. But I have got PW comma T, I do not have. But PW given T, I do have. Probability of T, I do have. So I can use this. So now what is probability of W is equal to red? So this is equal to probability of W is equal to red given topic is equal to rose into probability of topic equal to rows plus probability of, I'm just summing over all the t now. W is fixed, but t is varying over all the possible values, which is Rose and Jasmine in this case. Is this clear? So what is the right answer then? Okay, this is the right answer. So the point is that do not lose focus of the theory. Okay, if the chosen word is white, which topic did it come from? Means so you tell the probability or the your belief. If the chosen word is white, which topic did it come from? Huh? Jasmine. More likely to come from Jasmine. Okay, let us see. Probably. How will you do it? You will form the two variables, random variables W and T. How will you write this probability of? How will you write it? Probability that T equal to rows, comma, W is equal to white. Is this correct? Is this correct? Given, yes, because W is given to be white and T is, it can have any value. Okay, so this is what we have to find. Actually, not just this, we have to also find probability that topic equal to Jasmine given W is equal to white. The word is white. So we have to find these two quantities. Clear? So let's focus on the first one. What is probability of T given W? What do I have? I know probability of T, right, for both Rose and Jasmine. I know probability of W given T for all the words and for all the topics. So I know these things. I have to represent now my unknowns in the terms of knowns. How do I do that? Huh? Okay, I have to find P of P given W. I don't know how to do it. Let us say I write it as P comma W divided by P of W, which is the definition of this thing. I do not know Pt given W, but I can use this product rule to write it like P of W given T into P of T. Okay, I know this quantity, but Pw I do not know. What do I do with Pw? Yes, so marginalize. I know the joint distribution, basically, which I have found above, P of W given T into Pt, and then I marginalize over T. Right? Can you compute these quantities on your own? Then we can move forward. Anybody has any questions, any problem if I leave it at this? Okay. So, does the probability of the word Asia depends on which topic was chosen? Does the probability of getting the word Asia depends on which topic was chosen? Table. Okay. Let us see. Probability of write it mathematically first. Probability that word is Asia. What next? Given topic as, let's say, rose. The question is probability of word equal to Asia given topic as Jasmine. Are they equal or not equal? That's what we mean by this question, right? That probability of the word, does it depend on which topic it comes from? Does it come from Rose or Jasmine? So we can compute these quantities as we have done before, or directly we can compute. So it is 1 upon how much? 21, and this is 1 upon 19. So they are not equal. So the answer is yes, it does depend on which topic was chosen. Next is, does the probability of any word depend upon which topic was chosen? So we can find like this, right? Okay, so this brings us to the concept of independence. So just now we discussed, does the probability of word depend on which topic was chosen? So this dependence or independence can be mathematically formulated. So what does this mean? Probability of W given the topic, so my W depends on which topic it comes from. If it does not depend on which topic it comes from, this means it is independent of T, which means it does not matter whether it comes from Rose or Jasmine, the probability is the same. Can you prove it? Can you prove that if probability W, any W given topic equal to Rose is equal to probability of W given topic is Jasmine, then prove that this is also equal to probability of W. If they are independent, if they do not depend on which topic they come from, then they are just PW, means you can ignore given topic because that does not affect. Just like I asked you, okay, maybe first solve this question. I assume that to be X. X into T into X. Okay. Yeah. So basically, what it's a simple proof. It is like this. So you know probability of W is equal to probability of W given T into probability of T marginalized over all T, right? And you know probability, or you can open up the T, probability of W given T equal to Rose, probability of T equal to Rose, plus probability of W given T is equal to Jasmine into probability of T equal to Jasmine. Now you know that these two quantities are same. Take them out. This becomes probability of W. Something like given, let us say this is, let us call both of them as A, right? So this will become A times probability of T equal to Rose plus probability of T equal to Jasmine, which will sum to 1, right? Probabilities sum to 1. So this is equal to A. So which means probability of W is same as probability of W given T equal to Rose and is same as probability of W given T equal to Jasmine. Okay, so this is the concept of independence. You can also express probability of W given T is equal to, so the left hand side is equal to probability of W comma T upon probability of T, right? And you can take the PT to that side and you get this, right? It means, this is a slightly different connotation. It means that if you have joint distribution of two variables, then you can decouple them because they are independent. So you can decouple them as distribution of individual variables, the product of distributions of individual variables. So this is also an important observation. So read the comment. The comment says, if both topics have similar distributions of words, then we would have independence. That is, the probability of word does not depend on which topic was chosen. Let us see some other examples too. What is the probability that I will come to class given that today is Monday? What is the probability that I'll come to class given that today is Monday? You trust me a lot, thank you. I may miss also. Okay, but yeah, it will be a high value and they are certainly dependent, right? But if I ask you a question, what is the probability that today I will come to class given that the director is out of town? I'm not director, so given that in a small village of America there is cyclone. Are these dependent? They will be independent, right? So so these two factors will be independent. So probability, the joint distribution can be factorized, and equivalently, the probability that me doing something given what is happening in some small village of some small country, they are independent. Yeah. Yeah. Then you have to consider all the possible values of T. No, then the question will be different. Question will be probability of W given any T. They are same. Right? Okay. So the same concept can be viewed from different angles and it brings you to different intuitive understandings. Okay. This was the concept of independence. Now probability does the probability of the word Asia depends on which topic was chosen? We have already done this part. So probability of Asia, W is equal to Asia given rows. This value was how much? 1 upon 21. This is 1 upon 19. And this is how much is this? Okay, yeah. So 1 upon 21 into 0.7 plus 1 upon 19 into 0.3. Okay. Are the random variables W and T independent? So if I ask this question, what you mean by this, or what you need to do is, you find probability of every word given every topic and see if they are independent, or let's say probability of W, any W given topic as rows is equal to probability of W given topic as Jasmine, right? You can compare them and find out whether they are equal or not. And if you have multiple variables, like multiple topics, then you have to do it for all the topics, right? Now, continuous random variables. So you may not only get discrete variables, you may also get continuous variables. For example, size of the rows, size of Jasmine, like the width of the rows, height of Jasmine. So they do not have discrete values. How do you find probabilities for these? Let's say, what is the probability to find a rows of width less than 2 centimeters? What is the probability to find a rows which has a width less than 2 centimeters? So you need to get the distributions. Let us say these are my samples from the real world. I have got many roses and many jasmines. Only roses with their widths and their heights. What is the probability of finding a rose of width less than 2 centimeters? It's a difficult problem, slightly difficult problem. I can say, okay, I'll simply count the number of roses with a width less than 2 centimeter, and that will give me the probability, right? So in this case, I have got this one, 2, 3, 4. So probability is almost half, right? Given this sample size, but this is not all in all. I can find so many other roses also. So now next is, what is the probability of finding a rose of width less than 2 centimeter amongst all the roses of height greater than 1.5 centimeter? Can you do it from here? Okay, so how can we approach this problem? So you will say, I have two random variables, w and height, width and height. So you want to find probability that your width is greater than 2 given height is less than 1.5. Right? From these samples you can find such cases. What will that be? Width is less than 2, okay. Width is less than 2 given the height is greater than 1.5. How will you do it? I think it's not very straightforward. Should we come back to it after some time, or should we do it now itself? I think we can do it now. Okay, otherwise I'll forget. So how many examples are there? Okay, how will you approach this problem? Good. Yes. So there are two ways to do it. So one way what's your name? Dheeraj. The one way which Dheeraj has suggested is, you count the number of flowers with width less than 2 given and height greater than 1.5 divided by the number of flowers with height greater than 1.5. Right? So in a way, this is the numerator is the joint distribution and the denominator is the marginal distribution. So this is simple to calculate, right? You just have to count these values. The W is less than 1.2 and height is greater than. This does not qualify. This one does not qualify. This one does not qualify. Okay, let us say greater than equal to, because we have got exactly 1.5. Okay. Greater than equal to. So we have got one such example. Divided by 4. Huh? Is it 4? 5. Okay, fine. H is greater than 1.5, so 4. Greater than or equal to. But this is only from these samples. Are height and weight independent? Height and width independent. So okay, let us consider. Okay, estimating joint probabilities. How will you estimate joint probabilities from continuous variables? Let us say your x now is no longer discrete. Like earlier you had words, right? Words were discrete things. Let's say 13 or 14 of those words, and you could easily compute. But now your width, let's say the width, is a continuous variable with values lying between, let us say, 0 to 3. How will you find out? So what is the meaning of joint probability? So you also have got H. Okay. Okay, first let us focus on probabilities of single variable, let us say width. How will you find probability density of width? So what does it mean is, okay, my probability of finding width in the range 0.0 to 0. Or what was it, 2.1? Yeah, width. Okay. So my width is less than 2 centimeters. So if I can estimate a function integrating over which I can find my W's. That will be useful. Okay. The point which I want to make here is that your W's are continuous values, right? How can you estimate this thing from the plot? Yes. So convert a continuous variable into a discrete variable with the help of, you have read this concept before, quantization, right? Quantization. You quantize it. So, which is also called binning. Quantization or binning is the same thing. So you will make bins. So let us say this is something like this. So let us say my values between 2.25 and 2. So probability. This concept is called a histogram. So what I plot here is number of samples. Let's say if I observe a width of let's say 2.1, it lies in this bin, so this bin will get 1 block, right? Now I observe another width of 2.2, let us say, which again lies in this bin, so this will get 2 blocks. Now I observe another width of, let's say, 1.3, let us say, which lies in this bin, so I will make 1 block here. In this way I will keep constructing my towers, and let us say finally I get something like this. This height is this height is this height is this, and like that. Right? Let us say I got something like this. Then if somebody asks me the question, what is the probability that my W lies between 2.25 to 2.75? Can you find it out? What will you do? You will take, this is my 2.25 somewhere here, this is my 2.75 somewhere here. I will count the frequencies. That is, this is 1, this is, let's say 1, 2, 3, 4. Okay, so 1 plus 4, let us say 5, divided by total number of samples. Total number of samples. So this concept is called histogram. Histogram gives me a rough sample of the density, right? Let us say I construct a histogram with very small bin width. Very small bin width means my it's delta x, where delta x tends to 0, right? So what will I get? I will get a continuous kind of a distribution, right? From there, I cannot use sum, so I will use integration. Integrate. Let us say I want to find what is the probability that x lies between a to b, like 2.25 to 2.75. They are a and b in general case. So I will simply integrate over my px dx. So my px dx was something like this. What was it? Okay, something like this, right? And where was? Okay, somewhere here was my a, somewhere here was my b, and I can just calculate the area under the curve to find out. So this is my px. This is not frequencies anymore. These are px. So which means summation over px dx is equal to 1. You remember it from px is equal to 1. You remember it from your probability theory basics. So what is the probability of finding x in the range x to x plus dx? It is simply px times dx, because you assume that px is almost constant in that small range, and then you find out that area of that strip, and then integrate over all the strips to find your probability of x lying between a and b, right? Now what is the probability distribution function? Probability distribution function is the probability, is the probability that x is less than z, right? Actually, it should have been not 0 but minus infinity. Right? For the so probability distribution function is simply integration over px, where x varies between minus infinity to z. Is this point clear? Okay. So based on your intuition, can you please tell me some properties of this probability distribution, or it's called cumulative distribution function? So what is cumulative distribution? Can you tell me some properties? Okay, let me ask, what is P of infinity? What is P of minus infinity? What is P of z for any general z? Is it less than 0, greater than 0? Greater than 0. And what is dpz by dz? Okay, you know this is pz, small pz, right? Which is always greater than or equal to 0. Okay, right continuous. This is a continuous function, basically right continuous. Yes, if you have Dirac deltas, then it becomes left discontinuous. But if there are no delta functions, then it is continuous throughout. Okay. Same rules hold here, like sum rule and product rule, which we discussed for discrete case. That sum rule means you can marginalize over certain random variables. Product rule means that you have conditional distributions, conditional density, which you can multiply like this, and you can get the joint distribution, joint density. Then you have Bayes rule, exactly the same way. Okay, next. Okay. Yes, so we have discussed this, that probability density function is always, it sums to 1 when integrated from minus infinity to plus infinity. It is always greater than or equal to 0. Can you say it is always less than 1? Px Px is less than 1 for all x. Huh? Last slide? Yes? Huh? Okay, product rule is, this is a typo. So the probability of typos is very large. So yes, P of x is less than 1. Is this clear? Okay, less than equal to 1. Thank you. Another typo. Is this clear? Okay, this is not correct. This is let us say this is 1, this is 1.1. So this is my x, and I only find x between 1 and 1.1 always. So what is the height? What is this P of x? Because your condition is that it should integrate to 1, which means the area under the curve should be 1. So the height should be n. So Px is not less than 1. And this is a valid Px. So this property is not correct. Okay. Transformation of variables. Very easy concept. Given Px, given the probability density of x, what is probability density of x square? For discrete case, it is very easy to find. For continuous case, it is a bit involved. For voltage readings across, an example is given here. For example, you are measuring voltage readings across a resistor, and you know the distribution of the density of probability density of voltage, right? What is it for our Indian system? Voltage 220 or 30? 230, okay, let's say 230 volts. 230 volts voltage is there, but there is noise and there is earthing effect, there are so many other things, extra load, under load, so because of which there is some fluctuation also, right? But the distribution, if I plot from the samples, I can plot a distribution which will be mostly around 230 volts, right? Now somebody asks me, what is P of x square? Okay, I'm sorry. Let us say this is my value of voltage with respect to the ground. So it could be positive or negative, both, right? So so you know this is a sinusoidal wave, right? Sinusoidal with the V peak to peak, something, I think 120 or something, I don't remember the values. Something V0 and minus V0. Now the question is, this is your time. What is my, you can plot a distribution of voltage, something like this. This is V0, this is minus V0. Right? I ask you, what is the density of power? What is the density of power? What is power? Power is equal to V square by R. I know the resistance. So I want to find the density of power. So is it the same thing? Is it the same distribution? Will it have the same distribution or different distribution? One thing is for sure, it will never see negative values, right? So there is a more principled way to do this. The way is, okay, you know P of x, that is some distribution. You have a y of y as a function of x. This function could be anything, right? Now I want to find, given P of x and the function y equal to fx, find P of phi. How do you do that? The basic philosophy is, okay, so let us say this area, which is of width dx at point x. So, okay, let me not consider